Welcome back to the Deep Dive. Don't forget to hit like and subscribe if you want to catch all our deep dives.
Yeah.
So today, we're diving into The Life of the Cosmos by Smolin.
Ooh, The Life of the Cosmos.
It's really a fascinating book. It
This
blends physics and cosmology
reading philosophy.
and a little bit of philosophy in there too. Really challenges how you think about the universe. And some of the questions we're going to be exploring today are, well, why does the universe seem so perfectly suited for life?
Yeah.
Or could the laws of physics have actually evolved? I mean, these are some pretty heavy questions, but let's jump right in.
Let's do it.
What I really liked about this book is how Smolin just kind of brings together all these seemingly different fields,
Yeah.
like physics, cosmology, philosophy, to paint this picture of the universe as not just some like random collection of particles, but like a dynamic, evolving, and maybe even, dare I say it, like a living system.
That's a good word for it.
Yeah, that's pretty radical, right?
It is.
It's different from how we usually think about the universe, right? It's like we always think about the universe as this giant machine
Right.
governed by like these fixed eternal laws, right?
Exactly. Yeah.
But Smolin kind of throws a wrench in that whole idea right from the beginning.
Mm-hmm.
And he does it by focusing on something we're all pretty familiar with, light.
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 Okay.
I mean, yeah, it's essential for life.
Of course. Yeah.
But how does that like tie into the grand scheme of the cosmos,
That's a really good question. Well, he uses light to kind of highlight a key problem with the old Newtonian view of physics.
Okay.
The Newtonian physics basically suggests that everything eventually reaches a state of equilibrium.
Equilibrium.
Like, think about a hot cup of coffee.
Okay, yeah.
It's hot. It's steaming.
Yeah.
You leave it on the table, and eventually it reaches room temperature.
Right.
It's boring. It's lukewarm.
Yeah.
No more energy, no more gradients, no more anything interesting.
Yeah.
But life, the way we know it, thrives on energy flow and order,
Right.
that's the opposite of equilibrium.
So it's like life is like the cosmic rebel in a way.
Yeah,
It's like defying the laws of physics.
that is a great way to put it.
Yeah.
Yeah. And Smolin points to stars as the key to this rebellion.
The stars.
Stars.
Okay.
You see, stars, they're like these incredible powerhouses, right?
Yeah.
They churn out a constant flow of energy that prevents the universe from becoming that cold cup of coffee.
Right. So without stars, it would just be like everything would just be like this homogeneous, like lukewarm soup and nothing interesting would happen.
Yeah, exactly.
Like a cold, dead place.
It's like a cold, dead, boring place.
Yeah, yeah.
And there would be no energy gradients.
Right.
There would be no dynamism.
Yeah.
Ultimately, there'd be no life as we know it.
It's amazing.
Ah,
I always knew stars were important.
right.
I never thought of them as like the lifeblood of the universe, like keeping things out of equilibrium and kind of like paving the way for life to actually like flourish.
Totally, yeah. And this leads Smolin to another crucial point.
Okay.
He challenges the idea that simply breaking things down to their smallest parts will give us a complete understanding of the universe.
You mean like reductionism?
Yes. Reductionism.
Okay.
Like, if we know everything about atoms,
Yeah.
we know everything about, well, everything.
Yeah. I get that.
Right.
That makes sense.
But Smolin argues that it can't fully explain the universe.
Why not?
Well, think about it.
Okay.
Even if we understand everything about the fundamental particles, right? Like
Yeah.
the building blocks of matter,
Okay.
we still don't know where those particles came from.
Right.
We don't know why they have the specific properties they do.
That's a really good point. Like, even if you understand all the components,
Yeah.
if you don't understand how they interact
Right. Right.
and how they came to be,
Exactly.
it's like having all the pieces of a puzzle but no picture.
Oh.
You might be able to fit some pieces together,
Right.
but you're never going to see the whole picture.
You'll never see the big picture. Exactly.
Okay.
And this brings us to one of the most mind-boggling mysteries in physics.
Okay.
The fine-tuning problem.
The fine-tuned.
Fine-tuned.
So like someone carefully calibrated the universe for us.
I mean, it almost seems that way, right?
Right.
It refers to the incredibly precise values of the fundamental constants in physics,
Like, give me an example.
like the strength of gravity
Okay.
or the charge of an electron.
Right.
These values seem to be perfectly set to allow for stars, galaxies, planets, and ultimately life to exist.
Okay.
And if you tweak those values even a little bit,
Like what happens?
the universe, as we know it, would be radically different,
Oh, wow.
likely lifeless.
Okay, so what are the odds of that happening just by pure chance?
That's the question.
Yeah.
That has puzzled physicists and cosmologists for decades.
It's like the universe hit the cosmic jackpot. Okay, so what are...
So Smolin explores three main explanations for this fine-tuning.
Okay,
Okay.
I'm all ears. What are they?
Okay, so the first one, and perhaps the most familiar one, is the idea of a supernatural creator.
Okay, so like the intelligent design argument.
The intelligent design, yes.
Okay, got it.
But he also presents two other possibilities.
Oh, lay 'em on me. What are they?
Okay, the second one is a bit more philosophical.
Okay.
It's the idea of mathematical necessity.
Mathematical necessity.
Okay, so maybe there's only one logically possible set of physical laws,
Okay.
and we just happen to live in a universe governed by those laws.
So it's not fine-tuning, it's just, that's just how it has to be.
That's it. That's the only way it could be.
Got it. Okay, and what's the third one?
Now, this is where things get really interesting.
Okay.
The third possibility, and the one Smolin favors, is that the laws of physics themselves might have evolved.
Evolved. Like, they weren't always set in stone.
Not set in stone, they changed over time.
Whoa. That's crazy.
It is, and it's the foundation for Smolin's revolutionary idea about a universe that is not static,
Okay.
but dynamic
Okay.
and evolving.
Okay, so how does he explain that? Like, how would that work, that the laws of physics are evolving?
Well, he suggests that just like life on Earth, right?
Yeah.
Has evolved over billions of years, so too might the laws of physics have undergone a process of self-organization?
So instead of being, like, fixed from the very beginning,
Yeah.
they emerged from some kind of, like, cosmic evolution.
Exactly.
That's wild. But how would that, what's the mechanism behind that? How does he explain this evolution?
That's a good question.
Yeah.
Well, he draws on the idea of spontaneous symmetry breaking.
Spontaneous symmetry breaking.
Yeah, it's a process where a symmetrical system ends up in an asymmetrical state.
You're going to have to break that down for me. I don't get it.
Okay. Think of it like a pencil balanced perfectly on its point.
Okay.
It's symmetrical, right?
Yeah.
But eventually, it has to fall one way or the other,
Right.
breaking that symmetry.
Okay, I get the analogy.
Yeah.
But how does that apply to the universe and the laws of physics?
He suggests that a similar principle might have been at work in the very early universe,
Oh, okay.
leading to the formation of different particles and forces, right?
Yeah.
With their unique properties.
Okay.
In essence, the properties of particles aren't necessarily intrinsic, but could be a result of their environment and interactions.
So instead of this, like, static clockwork universe,
Yeah.
it's more like a dynamic, evolving ecosystem
Yes.
where even the fundamental laws are subject to change.
Exactly.
That's wild.
And this leads to one of his most mind-blowing propositions.
Okay.
The idea that black holes might be the seeds of new universes.
Hold on. Black holes.
Black holes.
Like those, like, cosmic vacuum cleaners that suck everything in.
Yeah.
They give birth to new universes.
They might.
Okay, I'm intrigued. Tell me more.
Okay, so Smolin proposes that these enigmatic objects might not be the end of the line, but rather the beginning of something entirely new.
Okay.
He suggests that inside a black hole, quantum effects might prevent the formation of a singularity, that point of infinite density we often hear about.
Right.
Instead, there might be a bounce.
A bounce.
A sort of cosmic rebound that leads to the creation of a new universe.
Okay.
With its own set of physical laws.
So each black hole is like a cosmic seed,
Yeah.
planting a new universe.
That's a great...
It's mind-boggling.
It is mind-boggling, but
But kind of poetic, don't you think?
it is kind of poetic.
But hold on, if new universes are constantly popping up, wouldn't that mean that there are countless universes out there?
Yes,
Each with its own unique set of laws.
that's exactly what he suggests.
Oh, okay.
A vast multiverse teeming with universes.
Okay, so then how would the laws of physics change from one universe to the next?
Good question. Think of it like this. Imagine that the parameters of physics, those fundamental constants we talked about earlier,
Right.
undergo small, random changes in each new universe.
Yeah.
It's similar to genetic mutations in biology.
Right.
Some mutations might be beneficial, leading to organisms that are better suited to survive and reproduce.
Okay.
In the same way, some changes in the laws of physics might lead to universes that are more likely to produce black holes.
So it's like a cosmic competition,
Mm-hmm.
where universes that are good at making black holes are the most fit
Exactly.
and have more offspring.
Yeah, they have more offspring.
That's a wild idea.
It's a wild idea.
But it makes a strange kind of sense.
Yeah.
But doesn't this raise some pretty big philosophical questions?
Oh,
I
absolutely.
mean, if the universe is evolving and constantly creating new universes
Yeah.
with different laws, what does that mean for our understanding of reality?
You've hit the nail on the head. Smolin's theory has profound implications for how we view the universe and our place within it. For one, it challenges the traditional notion of space and time as fixed, absolute entities.
Okay.
Instead, he suggests we consider a relational view of space and time,
Relational view.
inspired by the philosopher Leibniz.
So space and time aren't these rigid backdrops, but are defined by the relationships between objects. Like, my distance from you is what creates the space between us,
Exactly.
rather than us existing in some pre-existing grid of space.
Imagine space not as a container, but as a network of connections,
Yeah.
where distances and relationships between objects define the very fabric of space.
So it's all relative.
It's all relative.
Yeah.
This relational view aligns with Einstein's theory of relativity,
Right.
which showed that space and time are interwoven.
Relativity, yeah. I still remember that mind-blowing concept of time slowing down near massive objects.
Right.
But how does this relational view of space and time connect to Smolin's ideas about an evolving universe?
Well, if space and time are relational,
Yeah.
they're not static or absolute.
Okay.
They can change
Okay.
and evolve along with the universe itself.
So it's like a dynamic, ever-changing cosmic dance.
It is a cosmic dance.
Okay. This is making my head spin.
I know, it's pretty wild.
It's like the universe is a giant interconnected web where space and time are woven together and constantly in flux.
Yes.
But there's more, isn't there? What about this quantum entanglement thing?
Ah, yes. Quantum entanglement.
I've heard so much about that, but it always seemed pretty spooky to me.
That's another concept that challenges our traditional view of an objective, observer-independent reality.
You know, that idea that the universe exists out there separate from us.
Right. But quantum entanglement suggests that things are a bit more interconnected than we might think.
You're talking about that weird phenomenon where two particles are linked, even if they're light years apart.
That's the one.
So what if you poke one, the other one jumps, even if they're on opposite sides of the universe?
That's a pretty good analogy. And what's fascinating is that entanglement suggests a more holistic view of the universe.
Okay.
It implies that we can't truly separate ourselves from what we observe.
Yeah.
Our very act of observation might entangle us with the system we're observing.
So instead of being detached observers, we're actually participants in the cosmic drama.
We are all participants in the cosmic drama.
That's a pretty trippy thought.
It is trippy, and it leads to very interesting questions about the nature of reality and the limits of our knowledge.
Right.
If the universe is this entangled web of relationships constantly evolving and creating new possibilities, how do we even begin to grasp it?
Yeah, that's a big question. It sounds like we need a whole new way of thinking about the universe, but how do we go from these mind-blowing concepts to an actual scientific theory? How does Smolin propose we describe this kind of universe mathematically?
That's where we dive into the more technical aspects of Smolin's work.
Okay.
He proposes a quantum theory of gravity based on the idea of a discrete spacetime.
Discrete space-time. Wait a minute, are you saying that space and time aren't smooth and continuous like we usually think of them?
That's exactly what he's saying. Think of it like this. Imagine zooming in on the fabric of spacetime. Closer and closer until you reach a point where it's no longer smooth and continuous, but made up of tiny, discrete units, like pixels on a computer screen
Oh, okay.
or grains of sand on a beach.
So space and time have kind of a graininess to them at the smallest level.
They do.
That's a wild concept.
Yeah.
But what are these tiny units of space and time? How do they work?
Smolin calls these building blocks of spacetime spin networks.
Spin networks. Okay, that sounds pretty technical. Break it down for me.
Imagine a network of interconnected nodes and links, like a cosmic web. Each node represents a quantized unit of space.
Quantized. So space comes in these tiny, indivisible chunks.
Exactly.
Like the smallest possible Lego brick.
That's a great analogy.
Okay.
And what's amazing is that these spin networks, while discrete at the Planck scale, which is the smallest scale imaginable,
Right.
can give rise to the smooth, continuous spacetime we experience at larger scales. It's like how millions of tiny pixels on your computer screen can create a seemingly seamless image.
That's incredible. So even though space and time might be chunky at the most fundamental level, they appear smooth and continuous to us because we're seeing them from a larger perspective.
That's the idea, and here's where it gets even more mind-blowing.
Go ahead.
Smolin proposes that these spin networks, governed by the rules of quantum mechanics, can actually describe the dynamics of spacetime itself.
Hold on. Are you saying that gravity, the force that shapes the universe, emerges from the interactions of these tiny spin networks?
Exactly. Gravity is not just a force acting on objects,
Okay.
but an emergent property of the underlying structure of spacetime,
Wow.
as described by these spin networks.
That's a serious paradigm shift. It's
Well-
like the universe is playing a giant game of quantum Lego, and gravity is just the result of how the pieces fit together.
That's a great way to put it.
Wow.
And Smolin goes even further, exploring the possibility that time itself might not be fundamental,
Okay.
but emerges from a deeper, timeless structure.
Wait, are you telling me that time might not even exist at the most fundamental level? Now my brain is really starting to hurt.
It's a question that has baffled philosophers and physicists for centuries. What Smolin suggests is that at the most basic level of reality, there might be no time, no change. Time as we experience it would then be an emergent property of the universe, a way of describing the relationships and changes between different configurations of these spin networks. It's like saying time is not an absolute, but a story the universe tells itself as it evolves.
Wow, that's heavy stuff. This is some seriously next-level thinking.
It is.
So Smolin paints this picture of a universe that is constantly evolving, self-organizing, and creating new universes with possibly different laws of physics. But where does life fit into all of this? Is life just a cosmic accident? Or is there a deeper connection between life and the evolution of the universe?
That's a question that Smolin explores in depth, and to answer it, we need to take a closer look at how he sees the universe as a self-organizing system, one that's constantly pushing the boundaries of complexity and perhaps inevitably leading to the emergence of life itself. So, to answer your question about life, we need to look at how Smolin sees the universe as this self-organizing system, one that's constantly pushing the boundaries of complexity and perhaps inevitably leading to the emergence of life.
So life isn't just some happy accident,
Yeah.
just a random fluke.
It might be more than that.
Okay.
Smolin challenges that traditional view of the universe as this cold, indifferent machine.
Right.
And he suggests that life might not be an accident,
Okay.
but an integral part of the universe's evolutionary journey.
So instead of life emerging in a universe that's indifferent to its existence, he's saying that the universe might actually be conducive to life, even biased towards it.
That's what he's suggesting.
Okay, but how?
He points to the incredible complexity and order we see in the universe.
Yeah.
Not just in life itself,
Yeah.
but in structures like galaxies.
Yeah,
He
sure.
argues that galaxies are not just random collections of stars,
Okay.
but highly organized systems that exhibit a remarkable degree of self-organization.
Right. So you keep mentioning this idea of self-organization
Yeah.
being far from equilibrium.
Right.
Can you just remind me what that means?
Of course. Remember when we talked about that cup of coffee?
Yeah.
Cooling down?
Yeah.
That's equilibrium.
Right, right.
But life and complex structures, they work against that.
Okay.
They thrive on that energy flow, gradients, differences, constant change, and adaptation. They're dynamic, self-organizing systems that maintain this high degree of order and complexity.
Defying the pull toward equilibrium.
Exactly.
So galaxies are like these giant cosmic ecosystems,
Yes.
constantly churning with energy and matter,
Yeah.
creating and destroying stars, and maintaining their intricate structures over billions of years.
But that's a great way to picture it.
So there's this parallel between how galaxies organize themselves and how life organizes itself.
Here is.
It's like there's like a cosmic blueprint for self-organization
Yeah.
that kind of manifests at different scales, from
Yeah.
the smallest living cell to a vast galaxy.
And this brings us back to the fine-tuning problem.
Okay.
If the universe is this self-organizing system,
Yeah.
constantly evolving, experimenting with new structures,
Right.
perhaps those laws of physics aren't fixed,
Okay.
eternal,
Okay.
but emergent properties of this ongoing process.
Emergent problem.
Emergent properties.
So the laws of physics aren't like the fundamental rules of the universe, but they arise from the complex interactions within it.
That's what he's suggesting.
It's like saying the rules of the game emerge from how the players interact rather than being set in stone before.
Yeah.
Okay.
And this perspective offers a possible solution to that fine-tuning puzzle.
Right.
Because if the universe is constantly evolving,
Yeah.
creating new universes, then perhaps Those universes that are hospitable to life,
Right.
the ones with the right set of physical laws, are simply the ones that are most successful at replicating.
So it's like the universe is running a giant experiment,
Yeah.
trying out all these different sets of laws and
Yeah.
seeing which ones work best.
Exactly.
And working best means creating more complexity,
More self-organization.
more self-organization, and ultimately more life.
More life.
That's the idea.
Okay.
This brings us back to Smolin's idea of cosmological natural selection.
Right, right.
The universes that are best at creating black holes, which are the seeds of new universes, have more offspring.
Right.
And over cosmic timescales, this leads to a multiverse that's teeming with universes fine-tuned for life.
It's like the universe is like engaged in this grand evolutionary dance,
Yeah.
constantly creating and exploring new possibilities.
Yeah.
And life, instead of being this like marginal phenomenon,
Right.
it might actually be the driving force behind this cosmic evolution. That's the implication of Smolin's work.
Wow.
It suggests we're not just passive observers in this universe, governed by these fixed laws,
Yeah.
but active participants in this grand cosmic adventure.
It's a truly awe-inspiring vision.
It is.
One that fills me with like a sense of wonder and a profound sense of responsibility. If the universe is this dynamic, evolving system, then we, as part of it, have the potential to shape its future.
Yeah.
Even in small ways.
And that's the most important message Smolin leaves us with.
Okay.
His book is not just a scientific theory.
Yeah.
It's a call to action, a reminder that we are not separate from the universe, but deeply connected to it.
Right.
Our choices, our actions, our existence contribute to this ongoing evolution of the cosmos.
Life of the Cosmos. It's a book that I'll be pondering for a long time to come.
I agree. It's a book that invites us to look beyond the familiar, question our assumptions, embrace the mystery and complexity of the universe.
And that's what we strive to do here on The Deep Dive.
Delve into those big questions, explore the cutting edge of knowledge, and hopefully leave you, our listeners, with a sense of awe and inspiration. So if you've enjoyed this deep dive, be sure to like and subscribe. And until next time, keep exploring, keep questioning, and keep your minds open to the infinite possibilities of the universe.